So welcome to my mathematics videos as we focus on looking at earth geometry. So this is one of the questions that came in the ECZ exam under earth geometry. Now of course I've eliminated what is redundant, but they gave us points on the earth surface W, X, Y and Z, and they told us to use our pi 3.142 and our radius 3437, that is in nautical miles. Now you can see this is a line of a latitude that is 80 degrees north, and this is another line of latitude 30 degrees south, and this is a line of longitude 15 degrees west, and this is another line of longitude 105 degrees to the east. So these and those make up the points that we have been given. Now the first question there, if we look at the solution there, it says calculate the difference. So calculate the difference in latitudes between W and Y. So remember W and Y, so they want us to calculate the difference in latitude. So for us to calculate the difference, so I can say difference in latitude. So the difference in latitude, if you remember, W is on the latitude 80 degrees north and Y is on the latitude 30 degrees south. Now it simply means that if 2 points are on different sides of either the equator or the Greenwich meridian, north, south, west, east, if they're on different sides, you simply add to find the difference. But if they're on the same side, you simply subtract. So in this case, because this is north and that is south, so we definitely need to add. So that is going to be 80 degrees plus 30 degrees. So that is going to give us 110 degrees. So that is the difference in latitude. So that is what you need to remember there. The B part there says calculate the distance in nautical miles. So they want us to find in nautical miles between X and Z along the longitude. So remember X and Z, this is along the longitude, which is 105 to the east. So they want us to find the distance, between X and Z along the longitude. If you remember the formulas that we taught you, so the distance XZ, that is along the longitude, is simply given by theta over 360 multiplied by 2 pi multiplied by the radius of the earth. Now remember that theta there is representing, the difference in latitude. So that is what it is representing. So the difference in latitude where X and Z align, and that is what we calculated as 110. So this is going to be our theta there is going to be 110 degrees over 360 degrees multiplied by 2 by our pi 3.142 multiplied by the radius of the earth. They gave us to use 3437 nautical miles. So that is going to be 3437. Remember, this is in nautical miles. Please, you can use your calculator to work out that. If I use my calculator to work out that, if you're able to see 110 over 360 multiplied by 2 multiplied by 3.142 multiplied by 3437. So remember, we are having in this case 3437. What is that giving me? It is giving me 6,599.42 in this case. So I've left it to 2 decimal places, and this is going to be in what? In nautical miles. Of course, rounding off this to 3 significant figures would actually be very hard, so I'm going to just round it off to 2 significant figures. Remember, to 3 you would have ended here, but the number here greater than 5, you add the 1. You can't write a 10, so you shift the 1, so it would have been 66. And remember, before the decimal point, maintain the digits by adding the 0, so that would have been in nautical miles. So that is the distance between X and Z in nautical miles. Now I want you to remember that if you are calculating your distance in nautical miles and they want you to calculate the distance in nautical miles, and they want you to express in nautical miles, you can also use a short formula. Please take note of the value that we are having there. Now I want to show you, this is B1 that we are just calculating. I I want to show you a simple formula that you can use as well if it is in naught commas. It is only applicable when the distance is in naught commas. So the distance xz, you can also use and simply say theta multiply by 60 degrees. This is only true if your distance is in naught commas, where the theta there that we are talking about is representing the difference in latitude. So that is the difference in latitude. Diff in latitude, I've just abbreviated that. That's what the theta. And what's the difference in latitude between the point x and z? X and z, remember, that is what we call the 110. So it will be 110 degrees. We just multiply by 60 degrees. Remember, this is only applicable because the answer, the distance is going to be naught commas. So let's try to calculate that. 110 multiplied by 60, it is giving me a 6,600 nautical miles. So you can see that this is very easy. And in your paper one, mathematics, when you're dealing with earth geometry and they tell you, your distance is in nautical miles, please, you can apply this formula here and use it. All right, let's move on and look at the other concept that, they have actually given us. That is going to be B2. So now in the case of my B2 there, let me just also eliminate that so that we create space. So for B Roman 2 there, it says we calculate the distance again in nautical miles B2 y and between y and z along the circle of latitude 30 degrees south. So they want us to calculate the distance now between y and z, that is along the latitude. So remember, for you to calculate the distance yz, the formula that we apply would actually say theta over 360. Remember, people are going to be using different things there, but what is important is knowing what they represent. So theta over 360 multiplied by 2 pi, the radius of the earth, but we say cos of x degrees. What do I mean in this case? Remember, my theta in this case here, my theta in this case, when you're calculating distance along the latitude, my theta here is simply representing the difference in longitude. So it is representing the difference in longitude, and that x is the latitude. In other words, let me say, the angle of the latitude. So the angle of the latitude on which the 2 points are lying. So if you look at the distance yz, it will be equal to what is the difference in longitude. So if you remember, y is on the longitude 15 degrees west and z is on the longitude 105 east. Remember what we said, because this is on the west and that is on the east of the Greenwich meridian, what do? You add. So theta would be 15 plus 105 degrees, and therefore theta is going to give us 120 degrees. And x is representing the latitude. On what latitude are the 2 points? So if you notice, the 2 points are on the latitude 30 degrees. That's why they told you along the circle of latitude 30 degrees. So we just substitute there. So that is going to be, my theta is 120 over 360 multiplied by 2 times my pi. Remember, they gave us 3.142. The radius 3437, so that is going to be 3437. Then we multiply by cos of x. What is our x? It is 30 degrees. Sorry, but that is 30 degrees. You can actually put it now on the calculator and let's see what that is going to give me. So it is 120 over 360 multiplied by 2 times, times 3.142 multiplied by 3437 multiplied by cos of 30 degrees there. So that would be equal to, it is going to give me 6,234.84. I've actually left it, to 2 decimal places. But of course, like they tell you in the exam, to 3 significant figures, I can count 1, 2, 3. So I look at the number in front, it is less than that. So it will give me 623. Remember, before the decimal point you can put the the 0 for the place value, so that is going to be 6,230, and that is in nautical commas. So that is the distance between between y and z. That is the way you can calculate it. Now I want to show you another method. Please take note of this value that you're having. Because it is in nautical commas, you can also apply another simple formula for you to calculate the distance along the latitude. So the formula that you can apply, which I want to show you, yz, is simply, I can say theta multiplied by 60 cos of x degrees. This is only true when you're calculating your distance along the latitude. As long as it is in nautical miles, you can apply that. Remember, my theta there is still representing the difference. It is still representing the difference in longitude. My x is representing the latitude. Let's see if we are going to get that value. Remember, the value we got 6,230 nautical miles. So let's try to see. So what is my theta? It is 120. That is what we found. Multiplied by 60. Multiply by cos x is the latitude, which is 30 degrees. So you can work out that on the calculator. It is going to be 120 multiplied by 60 cos 30 degrees, the latitude on which they are. If you look at that, if you round it off there, it is definitely going to give you 6,235.38. Just slight differences that you're having, which when we round it off to three significant figures, 1, 2, 3, would be 6, 2, 4, and the 0. So basically that is what we have. So there's a slight difference that we're having, but of course this formula can actually help you to come up with a distance correctly. So remember, you can also use it in your paper 1. This concept can actually be used in your paper 1. Alright, so watch out for more videos under Earth geometry as we try to analyze distance along the longitude, along the latitude, and also I'll show you how to calculate the speed. If you like my videos, please, you can press that the like button, and you can also subscribe. Thank you so much for watching.